A deep dive into sklearn, linear model, Lasso CV. sklearn, linear model, Lasso CV is a powerful tool in scikit-learn for fitting a linear model with L1. Regularization lasso and performing cross-validation to automatically select the optimal regularization parameter alpha. Let's break down its key aspects in detail. 1. Core functionality. L1 regularization Lasso CV implements the lasso technique, which adds a penalty term to the objective function proportional to the absolute values of k coefficients. This penalty encourages sparsity in the model, meaning that many coefficients become zero. This is useful for feature selection and reducing model complexity. Cross-validation Lasso CV incorporates cross-validation to determine the best regularization parameter alpha. It splits the data into multiple folds, trains the model on different combinations of folds, and evaluates its performance on the remaining fold. This process helps to find the alpha value that generalizes well to unseen data. 2. Parameters. Let's explore the key parameters and their roles. Apes float. Default 0.001. This parameter controls the tolerance for the optimization algorithm. It specifies the minimum change in the objective function for the optimization process to stop. A smaller value of apes can lead to a more precise solution but may require more computation time. N alphas int. Default 100. This parameter determines the number of alpha values to be tested during cross-validation. Increasing n alphas leads to a finer search over the alpha space but also increases computational cost. Alphas array-like. Default none. You can explicitly specify the alpha values to use for cross-validation. If not provided, Lasso CV will automatically generate a sequence of alpha values. Fit intercept bool. Default true. This parameter determines whether to fit and intercept a constant term in the linear model, if you believe that the data does not necessarily pass through the origin. Setting this to true is recommended. Normalize bool. Default false. By setting normalize to true, you can normalize the features in the dataset before fitting the model. This can improve performance, especially when features have different scales. Precompute bool. Default false if precompute is set to true. The model precomputes the gram matrix dot product of the feature matrix with itself. This can speed up the optimization process but increases memory consumption. CV int. Cross-validation generator or iterable. Default none. This parameter controls the cross-validation strategy used for alpha selection. You can use integer specify the number of folds for k-fold cross-validation. CV generator provide a cross-validation generator object from sklearn model selection. Iterable supply and iterable yielding train. Test splits as arrays of indices. Maxiter int. Default 1000. This parameter sets the maximum number of iterations allowed for the optimization algorithm during each alpha value evaluation. Toll float. Default 1e-4 similar to apes. This parameter sets the tolerance for the optimization process, but it relates to the change in the coefficients. Positive bool. Default false. This parameter forces the coefficients to be positive if set to true. This can be useful if your problem domain requires positive coefficient values. Random state int. Random state instance or none. Default none. Setting a value for random state ensures reproducible results by controlling k randomization during cross-validation. Selection str. Default cyclic. This parameter specifies the strategy for selecting features during optimization. Cyclic uses a cyclic pattern, while random randomly selects the next feature. Verbose int. Default 0 controls the verbosity of the output during model training. Higher values provide more detailed information. N jobs int. Default none. This parameter allows you to utilize parallel processing for speeding up the model. Training. Setting n jobs to a positive integer specifies the number of cores to use. None will utilize all available cores. And -1 will use all available cores except 1. 3. Attributes. Once the model has been fitted, it stores useful information as attributes. Core array. This attribute holds the estimated coefficients of the linear model. Note that due to L1 regularization, many of these coefficients might be 0. Intercept float. This attribute stores the estimated intercept of the linear model. Niter array. This attribute contains the number of iterations that the optimization algorithm ran. For each alpha value, alpha float. This attribute represents the optimal alpha value selected by cross-validation. Dual gap float. This attribute provides the dual gap for the optimal value, which can help to assess the convergence of the optimization process. MSE path array. This attribute contains the mean squared error MSE for each alpha value considered. During cross-validation, this information can be helpful to understand the trade-off between model complexity and performance. N samples fit int stores the number of samples used to fit the model. N features in int stores the number of features used to fit the model. Feature names. An array stores the names of the features used to fit the model. If the input data has feature names. 4. Methods. Fit x, y. This method trains the Lasso CV model using the input data x and corresponding target values y. Predict x. This method uses the trained model to make predictions on new data x. Score x, y. This method calculates the coefficient of determination R2 for the predictions made on the provided data x and target values y. Get params. Deep true returns a dictionary of the current parameters of the estimator. Set params. Quarks sets the parameters of the estimator. 5. Example. Python. From sklearn, linear model import Lasso CV. From sklearn, datasets import load diabetes. From sklearn, model selection import train test split. Load the diabetes dataset. Diabetes load diabetes. X diabetes, data. Y diabetes, target. Split into training and test sets. X train. X test. Y train. Y test train test split X. Y. Test size 0.2. Random state 42. Create Lasso CV model with cross-validation. Lasso CV CV5. Random state 42. Fit the model. Lasso CV. Fit X train. Y train. Make predictions on the test set. Y pred Lasso CV. Predict X test. Evaluate the model. Print F optimal alpha Lasso CV. Alpha. Print FR2 score Lasso CV. Scores test. Y test. In summary, Lasso CV is a powerful tool for fitting sparse linear models and automatically selecting the best regularization parameter. It is suitable for various tasks involving feature selection, model simplification, and prediction in high-dimensional datasets.